Good morning to all of you. My name is Anurag, Assistant Professor in Department of Civil Engineering, IIMT University, Meerut. Today I am going to take a lecture in very interesting subject that is called design of concrete structure. All of you are aware about this is a very designing subject for the civil engineering students and especially structural engineering students who are doing the MTech in structure. All of you know that what is the concrete? We know that concrete is the binding material of cement, sand, aggregate and water. Look at here. First of all, in upcoming slide we will discuss about the introduction to design methods in reinforced concrete. What kind of a design methods is going to use in past days. We have done the design of concrete structure with respect to design of limit state method, and we have done the designing with respect to working stress method. Limit state method is we are currently used for the RCC structure. In last several years, when there is some kind of a disadvantage and the deficiency in working stress method, then we have to introduce the limit state method. So this is we will study about the introduction to the design methods in reinforced concrete. Reinforced, where we have to use there is a different types of a cement concrete structure like plain cement concrete, reinforced cement concrete. Why we are using reinforced? Because reinforced cement is like a rebar with the different types of grade of steel we are using, like Fe415, Fe250, Fe600, Fe550. Just like we have to say, if we are using the Fe250, we can say it's a mild steel. If we are using a Fe500, 550, we have to say it's a CTD, cold twisted bar. TMT Saria, we have already know about we have to say this is the TMT Saria. What is the meaning of TMT Saria? This is the actual mean that the TMT means thermomechanical treated bars have a different parameters, we have different meters, we have to consider in a Newton per meter square. Just we have to say if the reinforced cement is between 550 and carry the load and strength about the tensile strength about the 550 Newton per mm square, then we have to say it's a cold twisted bar or the TMT bars, and HYSD like 450 plus rest of the strength. Then sustainable construction is concrete, either it's a green. Means sustainable construction is very important, because in right now our era, in upcoming generation, right now this kind of a generation, we have to go for the green construction, where greenery is very important factor. Environment should be just neat and clean. Everything, the rainwater harvesting, we have to consume the water, we have to store the water, then we have to use for our work. Then possibility in the concrete structure, what kind of a possibilities we have to make in construction and reliability, that should be very important for upcoming generation and upcoming era. So there is a different possibilities, because we have to make the greenhouse concretes, we have to make the greenhouse building structure. We already seen the different countries are going to follow up the such kind of a methods. That should be very important to be live very passionate, honestly and happily on this beautiful earth. Now come to the next one. What are the technical concepts should be understand while we are going to design the reinforced cement concrete structure? So there is several types of things we have already studied in previous classes, like the strength of material, and we already discussed about what is bending moment and how to represent the bending moment diagram, what is the shear force and how to represent the shear force diagram, and what is the real difference between the bending moment and the shear force diagrams. Now reinforced and pre-stressed concrete, this is very important. Pre-stressed concrete is very important while we are going to design the pre-stressed concrete. Pre-stressed concrete and reinforced concrete. So reinforced concrete is reinforced means we have to use such kind of a pre-stress. The reinforced cement should be, first of all, concrete should be put in the structure, and reinforced means we have to make the steel bar should be stretched out. Then we have to see pre-stress member. We also say the post-stress member, post-tension member, pre-tension member. What is the meaning? This type of a concrete should be made on the industrial side, and we have to make such kind of a concrete on the steel side. And what are the strut and the tie methods for the design of concrete structure? This is the different. Just like a column, we have a column should be a vertical. That's why the column is a compression member. But while we are talking about the strut, the strut is also like a compression member, but it should be the horizontal. Okay. Now come to the next slide. Look at here. Stresses in banding, reinforced concrete versus pre-stress, design methods, environmental issues, design possibilities, and the conclusion. You have to see next page. What is unreinforced concrete? Same as masonry, same as masonry work. Masonry work, there is a different types of masonry work, but as per the civil engineering knowledge and exploring the knowledge, we have to understand the brick masonry and the stone masonry. Same as the masonry, it must act in compression. It must act in concrete in compression. Look at here. Outline. We have to understand what is the introduction about the concrete as a material. So we have already known concrete is the binding material of cement, sand, and aggregate. What kind of stresses should be phased out in while the structure should be in the bending moment? What is the reinforced concrete versus pre-stress? Design, there is a several design methods like a working stress and the limit stress method. Environmental issues while we are going to construct the different kind of a structure in different, if we are doing the structure, we are doing to making a high rise building in a porch area, what kind of a things we are facing. If I am going to construct in a rural area, what kind of a material and what are kind of a environmental issues I am going to face out. If I am going to make a structure or the high rise building or the mall or the public building or hospital, mercantile building, any type of a building, there is several types of environmental issues we are going to face out. Design possibilities, how many design possibilities should be aware, we have to aware about the design possibility, that should be economical, because as a civil engineer, we have to understand how much economy and factor of safety should be taken out for the design of different kind of a reinforced cement concrete structure. Now we already know the conclusion. Look at it, same as masonry, it must act in compression. This is a Roman Pantheon in 126 AD, and masonry work should be part of a compression. So there is no any kind of a resistance in tension. Then if we know that concrete is weak in tension, that's why we are going to use the reinforced cement. Understood? And concrete is already, we know that the compression member, and we have to depend on this. So this type of a structure, it must act in compression, there is no resistance to the tension. Next slide. Bending of reinforced concrete. Handbrake system patented in France. First in the history of we are going when the beginning, this is a history of the reinforced concrete. This is a different kind of a structure, and you have to see here, look at here, this is a beginning of reinforced structure when the true structure should not be tied out, and the structure should be from, look at here, from this structure to this structure, that should be stretched out. In next slide, you have to see the bending stresses in different types of a beam. The bending stress, this is a beam and the stress should be on a point load. Then we have to understand the neutral surface and the neutral axis, where force in the tension should be represented by Ft and force in the compression side should be represented in Fc. Compression should be compressed, the structure should be compressed, the structure should be, when the point load be carried out, there is several types of a load should be here, and due to point load the structure may be either the structure should be either fall out here, and due to movement it will be fall out here. So when we have to count the compression, then we have to write down the Fc, and when we have to consider the tension, when the structure should be feel like a tension, then we have to consider for the Ft, and sigma T is the stresses. This is the force for the compression side, force for the tension side, and sigma T represent the simple stress and all. Steel reinforcing in concrete, very important. When the steel, why we are not using the diamond, platinum, copper, steel? Why we are using the steel for the designing of reinforced cement concrete? Because first of all you have to understand, because the thermal expansion and with respect to coefficient of thermal expansion with respect to concrete with steel is slightly matched out. Steel is economical as compared to other binding material. Just like if I am showing diamond is already too much costly, steel and gold is so much costly, so we are not considering. Steel is 78 rupees per kg, and the gold, any kind of a binding material is steel is suitable with concrete. It will give high strength. 19th century invention should be done, while the steel reinforced cement in concrete is using for the design of reinforced cement concrete structure. In 19th century invention should be done with respect to this diagram. You have to understand how the forces should be goes out and how it will be reflect. Now come to the next slide. Design basics for the reinforced concrete. Design basics. This you have to take. This is a simple stress diagram, and concrete must be cracked in order for the reinforced cement steel to carry the load. So tension area. This is a rectangular diagram, stress strain diagram. Then we have to see if the compression side should be represented for the. We have to find out the area of concrete. Then we have to count out the area of steel. So how we have to consume when the tension should be. This is a reinforced cement. This you have to see the reinforced cement. Look at here. Tension area should be represented by area of steel S, and the compression area should be K into D into depth, and D. This is a D level R. Now and this is the bit. You have to see in the next slide. Pre-stress concrete, very important. Now the area reinforced concrete versus pre-stressed concrete. You have to see pre-stressed concrete. This is a reinforced concrete where there should be hand cracks under the load plus self weight. It should be give the stress means compression zone and tension zone. While I am talking about the pre-stress means no cracks, no tension. Here have to be maintain the cracks under the load. But while we are going to study about the pre-stress concrete, there is no any kind of cracks, no any kind of there is a tension. Pre-stress member should be look like a triangle. When we have to understand the load plus slave weight, it should be like, and the final stresses should be like a triangle. That's why what is the advantage? Reduce the tension cracks. Tension cracks means when the reinforced cement should be provided, there is a several types and different types of a crack should be carried out while we have to design any kind of a structure. That's why we have to reduce the tension side of a cracks. Reduce the deflection by picometer, reduces the depth, that should be more efficient. Now you have to see the diagram, reinforced and pre-stress. There is a several point of load. It will be, there is some kind of a too much bending, but there is a little bit approximate negligible bending moment. Come to the next slide. Principle of reinforcing. First, we have to load. You have to look at the diagram. Simply supported beam over the different types of load. Then we have to make it the moment diagram, bending moment diagram, where the load should be maximum. There is a load should be maximum. There is a curve should be also a maximum. Okay. Reinforcement concreting beam. Reinforcement steel is placed in tension region. Tension region we have to place the reinforcement, and we have to create the, again we have to make the post tension beam, like a cable is draped to reflect the moment is present. Look at the diagram. Loading, then movement diagram, then reinforced concrete beam, reinforcement steel is placed in tension region. Then you have to see the diagram. And this is the pre-stressed concrete member or the post tension member. Conventional design, we have to determine, there is a different types of design method. Like we have to do the conventional design. First we have to determine the movement diagram. We have to find out the movement of resistance. Then we have to specify the steel in area of tension. How much steel of amount, how much amount of steel is required for design of any kind of reinforcement concrete, either it is a beam, slab, column, footing, whatever be the type of a structure, we have to specify the steel in area. So we have already understand in the upcoming chapter when we are talking about the limit state method, we will have to design singly reinforced beam, doubly reinforced beam, T beam, different one-way slab, two-way slab, compression member, short and long column. All of the certain different types of a structure we will design with respect to the conventional design method. Now come to the strut and tie methods. We have to define the internal forces in tension. First of all, we have to find out the internal forces in tension zone and compression is either it's a tie and or strut. Then we have to specify steel in area of tension. Then we have to make it the strut and tie methods. What is concrete? Look at here. Air, cement, water, 20 to 27% of sand, 40 to 45% of aggregate. This all make the composition material of concrete. Look at here, cement, sand, aggregate and water. Means how much amount of percentage of required for making the binding material of concrete. So look at here, 40 to 45% of aggregate, 20 to 27% of total amount of weight of concrete, sand, then 14 to 18% water, 10 to 12% cement, and 3 to 6% should be air. Comes next to the slide. Is concrete a green material? Yes, obviously. If we are working as an engineer, as a scientist, we are doing now greenhouses are making possible to make a green concrete. Now bacterial concrete is also used for designing or different kinds of reinforced structure. Look at construction and the environment. Look at here. In the United States, building account for 30% of total energy is used, 65% of electrical consumption, 30% of greenhouses gas emission, 30% of raw material use, 30% of waste water output, 136 million tons per year, 12% of potable water should be conserved, and the US Green Building Council 2000 gives such kind of a building accounts and the construction and the environment. How is the relation between the construction and the environment? This is a very linear relationship. If we are making the environment should be polluted, then construction and the living method should be very rough and tough. Okay. Construction waste. New construction 8%, demolition 48%, and renovation should be 44%. With the Venn diagram you have to see how much amount of construction. New construction all over world should be 8% or any kind of figure out. Demolition 48% and renovation is going to be take a charge of 44%. Look at here, US Environment Protection Agency EPA estimate that 136 million tons of waste is generated by construction each year, and the most result from the demolition, the renovation, and the nearly half the weight is concrete. This is a specific and very unique report. Embedded energy per stiffness, wood, brick, concrete, steel and the aluminum. This is a percentage you look at here. Energy required for the concrete. Portland cement percent by 12%, energy should be required 92%. When we are talking about the cement, percent by weight is 34%, energy should be 2%. When I am talking about the crushed stone, 48% by weight and the 6% by energy. And the water, when the percent by weight 6% and the energy by 0%. This is each ton of the cement produces 1 ton of carbon dioxide. Look at here. Corrosion of reinforced concrete. We are talking about the corrosion effect. Look at here diagram. This is a corrosion effect. This is a very important. We have to aware how we have to take the precaution while we are going to do the reinforced concrete structure, because steel is also a binding material, okay, with respect to cement, sand and aggregate. Look at here. This is a corrosion effect of RCC structure. So we have to take care of, because it is very important to take care of such kind of a structure while it will be affected by the corrosion effect. We have a solution, don't worry at all. In the United States, the overall cost of the reinforced steel corrosion have been estimated at more than 150 billion per year. A particular problem for highway bridges due to dry icing salts. This is very important. Corrosion prevention of RCC. Simplest method, maintain the concrete in compression and provide the greater cover of concrete over rebar. This is a very important and the very simplest method. Any type of a structure we are going to make for the designing of reinforced cement concrete, we have to aware and maintain the concrete in the compression and provide the greater cover. Either it is a 25 mm, we have to make it more cover to prevent the rebar. More complicated and more expensive. We have to protect the steel with epoxy coating or by using the stainless steel rebar. Use the non-metallic reinforced cement such as carbon or color, but these materials are expensive and energy intensive. Come to the next slide. Maintain the concrete in compression as much as possible. Follow the movement diagram to minimize the material use. We have to detail design, prevent the water infiltration, protect the steel, specify the use of fly and recycle all kind of a concrete structure. Good practice in concrete. What kind of a practices is required while we are going to design the concrete? Consider the precast concrete system which can use considerably the less concrete. Specify the fly ash which can improve the workability and strength, and swellies help to recycle the waste. Next one, use the concrete waste as fill whenever possible around the buildings or an aggregate under the parking lots and driver keys. Reduce the waste water through design by eliminating unnecessary concrete, like use the smaller transfer beam in the state center. Now come to the conclusion of very basic. This is a very basic sub concept. Now you have to understand the conclusion. Concrete will continue to be a dominant construction material. Already everybody knows that concrete is a dominant material for the designing of any kind of a structure, especially when we are doing and going to take care of the limit state method, like limit state of serviceability and the limit state of collapse. Reinforcement concrete must crack in order for reinforcement to work. Lower durability because steel can corrode. Pre-stressed concrete prevent the cracking. Two powerful design methods like movement diagram or strut and tie methods, and environmental impact can be reduced through the design. Now come to the next one. Thank you for listening my lecture. In upcoming lecture I will discuss what is the basic concept while we are going to do the cement concrete, and while we are going to design the reinforced cement concrete of singly reinforced beam and doubly reinforced beam or the T beam. Thanks, and wait for the next lecture.